Okay, good morning, everyone. Welcome to grade 7 coding. It is the 6th of July, and we are going to be looking at functions in Minecraft for puzzle 10 to 12. And if we get to do more, then we will continue into the next lesson. I'm also going to give you a very short introduction on binary code and what it is. Now, that in itself can be an entire lesson because it really has a lot to it, but it was a question that came up within this lesson before, in this class before. So I am going to quickly touch on that. Before we get going, I just want to quickly welcome anyone that might be new and then welcome all of our previous students back. I hope that you enjoy these lessons, and I hope that you can invite some of your friends to come and join us here. They can visit the Africa Teen Geeks website, and then they can register for our the newsletter and receive the links to the lessons. One more thing is, if you are new, the chat box is there to ask questions and for me to answer them, and I share links with you so that you may see or do on your computer what I do on mine. So please refrain from chatting about things that are not related to the lesson. As well, try not to, or please don't share any links. The moment you do, it creates a lot of hassles for us. And lastly, do not switch on your video camera, and this is not because I don't want to see your lovely faces. It's just that when you switch it on, I cannot see my screen anymore, and then I am stuck and I can't teach because I cannot see the content. Okay, so I think we are good to go. I just want to double check everything one last time, and then I think we can continue. Awesome. Right, so there is a quote from Mark Zuckerberg, and this is a quote that he made, or a statement that he made in 2014 at the Computer Education Week hosted by Code.org. So Code.org is the platform that we're working on, and as you can see here, Mark Zuckerberg actually does some of their videos for them. And for those of you that don't know who Mark Zuckerberg is, he is the CEO and founder of Facebook. He's the one who started Facebook. So you can see that the platform we're using is backed by some big names in the industry, okay? So he says, in 15 years, we'll be teaching programming just like reading and writing and wondering why we didn't do it sooner. So this ties into the quote that we had last week, where we said that if you want to pursue any career in the 21st century, you should have basic programming knowledge. If not, you should have at least basic computer and computer science education, knowledge, right? Okay, so let us see. Here are some terms that we need to know, some things that we have to have a look at. So these words are things that we will see often and that we have to take note of and know. So what I would want to do is, from now on, I'm just going to touch on some of these words that we see often and the ideas behind them. So the first one is loops, right? So what a loop is a sequence of code that repeats itself a set number of times. And we can set how many times that sequence of code will repeat itself. Okay. Another thing to take note of now is that, just quickly check the chat here. No, coding is not yet a curriculum. We are working hard with the Department of Basic Education to bring coding into the curriculum. We have created an entire curriculum around coding. We've also created a platform that is based on South Africa, or that has some South African things in it, that will also where we can code using Blockly as well. So for now, it is just an informal subject that we are teaching because it's a good skill to possess, and we are trying to figure out exactly how we will go about and testing how we can practically teach these things. Okay, but at the moment it is not it is not in the curriculum. Okay, so where was I? A sequence is code. Okay, a sequence. Now, what we need to remember here as well is each one of those little blocks that we have when we are creating a sequence is also known in block line and text-based coding as a statement. Okay, so a sequence is compiled of many statements, right? So the next one we have to look at, and this is one we're using at the moment, functions, a sequence of code that performs a task or calculates a value. So we now know that we are using functions in these lessons to perform a task. Okay, so we are using these functions and we call on these functions so that each time we do call on them, the agent will actually perform a task. Okay, let me just quickly check the chat box again. Okay, so on the Minecraft Education Edition, I did share those links to those that did ask. So I don't use that. I haven't used it before. As I said, I'm currently busy with Microsoft's STEM learning path, and I saw people speak about it. So I went and I had a look at what it is, but I didn't go any further. I just saw what it is and that it is something that seems to be available, but how it works exactly, I'm not sure. So what you would have to do is just ask your parents to assist you and to find out exactly what you need to do. We don't use that here at the school. It's not necessarily something that is endorsed by us, but it is something that I personally saw while I am furthering my studies and that I thought I could mention to you. Okay, so with regards to if you need a student's email or what you would need for that, I am not certain. As I've said, I do not use it. We play Minecraft on the Xbox and the Education Edition is only available for the PC version. So that is unfortunately the only information I can give you on that. Okay, now I think we need to get into binary code. So you've mentioned this in the chat box before, and you asked me about what are the ones and zeros that with regards to computers that you have most likely seen people speak about in movies or heard people talk about. So these ones and zeros, they create a string and they represent information, okay? And this is called binary code. So what binary code is it is a method of counting. So we have to go back quite a couple of years, and the things I'm explaining to you now, it isn't used exactly like this anymore because technology has advanced, but we need to understand the beginning of something to know or to fully understand how it functions now. So way in the beginning, I'm talking about many, many, many years ago, when people wanted to count things, to know how many things they had, and they wanted to write that down to, for example, keep stock. Let's say you had a fruit stall at a market and you wanted to know how many things you had and how many things you sold that day. Then you would have counted that and you would have written it down somewhere. Then the way they used to do that, they didn't have a numbering system like we have today with the 1 to 9 or the 0 to 9, and then once we reach 9 we put a 1 again and we start the right hand side on 0 again, giving us the ability to count very far. So what they used to do is they just used to draw lines on a piece of paper. You've probably seen this when people are trying, let's say somebody's stuck on an island in a movie and they want to count the amount of days that they're there. They usually draw those lines. They draw 4 of them, and then the 5th one, they cross out all 4, and then they know that's a group of 4. So that was the initial way of counting things and how to and to measure the amount of something. Then they developed binary code, and binary code is just that. It is a way of counting, okay? So it is more effective, a lot more effective than drawing the lines, but it is not yet as effective as the counting system that we are using. It does, however, work well with computers, and I'll show you why that is now. So if you look at these little black things, these are actual parts inside the computer, right? Hardware parts. Now this is more, they are still in computers for today, but the way they're being used now is a little bit different. But in the first computers, these little guys, they're known as transistors, okay? And what it would be is they would group 8 transistors together, and these 8 transistors together would be known as a bit, a bit. And if you were to insert binary code, you would have 1 being an on and 0 being off, right? So if you look at this, this is 1 0 0 0 0 0 1 1. So we have 1 off and sorry, on, then off, 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 on. Okay. So these things being on and off, the only thing that they are doing is they are actually creating a number, okay? And that number gets translated by the computer into text that we can read, into our alphabet that we can read. You can imagine if you had to open a Word document to read something, or you wanted to read an article on the internet, and it looked like this, and you had to go and figure out these 8, 1, 2, 3, 4, 5, 6, 7, 8, the first 8, what letter that relates to, and then check the next 8 to see what letter that relates to, and so on. It would take you forever to read. So the system works that if by using 8 of these, there are a total of 255 possibilities that you can have, right? Different combinations of this, and they get translated by the computer into characters that we can actually read. So here you can see the BIN is the binary code, and on the right hand side is the character that that code relates to. So if we have a look at a 0, 1, and then all those zeros afterwards, the computer will display that as a space. Okay, but when we type a space on a Word document, the computer doesn't save the space. It saves it in binary code on the hard drive. Now, the hard drive doesn't use these things, right? They use spinning disks and they use magnets to do what they do. But you have to understand this idea before you can understand the other idea. So what the binary code does is it allows the computer to translate information that we give it in line and text-based form and translate that into something that the computer can read and understand, and then it can again translate that back to us from a binary code into characters that we can see. So the question was asked in one of the previous lessons, how do we write binary code? So you can write binary code like this, but when it comes to computer and computer programming, we as programmers, we do not actually write the binary code. What we do is we use line and text-based coding, so we create code using these characters that we know and that we can all read and understand, especially ones like the curly braces and the letters we use often. Now, these are obviously uppercase letters and there are lowercase letters there. And there are some other things that we use. The parenthesis is something we use in coding. The semicolon is something we use in coding. Okay, and the underscore. So we write those actual characters into our program, game, or application. And then this gets translated by the computer into binary code so that it can efficiently store the information, right? Because it is easier for the computer to store a document like this than it is for the computer to store a document that is typed out in these letters and things. And then it is faster for the computer again to read this and translate that back into these letters and text and line for us to read and for us to understand what it is that the computer is telling us to do. So obviously when the computer is using binary code to understand system processes, it doesn't have to translate that into language that humans can understand. It just keeps it in binary code. So I'm talking about now the communication between your processor and your hard drive as an example. These are hardware elements of a computer. So these two, they do not need to translate when they need to communicate with each other. They don't have to translate that into line and text. Sorry, I skipped there. Into this, they can just keep it in binary code because both of those hardware devices, they understand binary code. Okay, so that is basically what it is. It's a way of counting. So all of these can be translated into a number that is on the 1 to 10 or 0 to 10 system that we use, and that number can also then translate to one of these letters. Okay, so that's all it is. It's a way of counting, and then each number in the sequence of a bit like this has been assigned a character. Now in today's computers, there is use for much more information than only these characters that you see here. So they have now begun to take 8 transistors, and remember, it isn't necessarily a transistor anymore that looks like this. It might be much smaller, or it might be just a magnet thing on a spinning disk in a hard drive that is either on or off. And they have now added another row of that next to, so that there are 16 of them in a row, and that allows for, I think, 35,000 possibilities of how these things can be set to on and off, and how that can translate to information that comes our way. Okay, so you can imagine on the internet how much information there is and how much different types of information there is. So this is what binary code is and what it is used for, but it is not something that we need to concern ourselves with. It's good if you understand it, but you don't need to worry about it too much, because as I said, we don't actually create this. Okay. So I hope that makes sense to you all. So for today, let me just check here quickly. That's a good question. I did not study up on who created it. I'm more concerned with how it works, but I will find that out for you. Although a basic Google search should give you an answer on that. Okay. You are obviously very comfortable with using computers, so you should be able to find that info, but I will also look for it. Right. So for today, we're going to look at this functions in Minecraft. Okay. Remember when we were right at the beginning, we said that a function is a way to calculate something or to let something happen. Okay. And it is a sequence of code that will do that within a function, and we can call on the function whenever we need to. Right. And then if we are finished with these two, we will also start with functions in the harvester. But I want to spend some good time here, because in the harvester, it becomes a lot more difficult. And I'll show you why. But for now, we are doing it in Minecraft, and I want to be sure that we understand it very, very deeply. So we're going to do each exercise in the Minecraft. We only have 2 left. In different ways, so that we are practicing the same thing, but in different applications. Okay, so now let me jump to that coding screen of mine. This is lesson 10. So this one, I actually want to start over. And I'm going to share the link with you all in the chat box. Okay. Good. So this is asking us our first question. So I'm going to start explaining while you navigate to the link. And just in case I see some new names here, I am going to quickly just talk through the GUI, the graphical user interface, so that we can all understand it, right? So in computer language, we speak about a GUI, GUI, and what that stands for is the graphical user interface. So that is where we as humans interface or interact with the computer, and we use graphics to do that because we respond better to graphics, right? Computers don't need pretty pictures, they just need code, but we want the pretty pictures. So what we have here at the right at the top, for those of you that are new, this is where we navigate to our other lessons and puzzles. So my advice is, when we're finished here and you close Zoom, keep your Google browser open so that you have access to this, and then you can go back. As you can see, we are on lesson 16. You can actually go back to lesson 1, and then you can go and do all of those from there. You just need to save the link somewhere, and then you do not need to sign up for code.org. Although if you want to ask a parent to sign up for you, it is absolutely free. They just need to have access to an email address, right? So here on this side, we see the puzzle. So the white ones are ones that we haven't done, and the green ones are ones that we have done. Now these white ones we have done, but this is where we changed over to the 2020 version. Before this, we were still on the 2019 version. So code.org is tracking our progress differently on 2019 and 2020. They're not carrying over progress, okay? So from there, you see the instructions here at the top, and these instructions tell us what to do and many times how to do it. I am here to teach you why we do these things, okay? Code.org is very good at training you as what to do and how to do it, but understanding really deeply why we are doing certain things, that is why I am here. So on the left, you can see is our play area, and you can see that I've made it larger now. You can make it smaller as well. And this is where we will see all the magic happen. Right next to that, we have our toolbox where we have many different blocks of code. So all of these things are blocks, and it translates to a statement in text and line-based coding. And these blocks do different things, and we'll discuss each one as we use them. And where we use them is here on our workspace, and you'll see this workspace doesn't have any restrictions, but some of them they do. They will tell us that we are not allowed to use more than a certain number of blocks. So in our workspace, this is where we will actually be creating our code. And the first thing we need to take note of, you can see it here in the instructions. It says, can you spot the difference between the two functions in your workspace? So here we can see we have a fixed long path, and this is a function, and the green one is the function's name. And here you can see there is the function in a block available for us to use, but this is where we define that function. So what we have said there is each time we are going to put that if we are going to put this fixed long path function in the code, then all of these things, this entire sequence, this group of statements, all of those will happen for each time that this block has been placed in the code. And it doesn't matter where we place it or how many times we place it. We can call on this function over and over again in one sequence of code or in an entire program. Usually when you're writing larger programs, you define your functions and your variables, and then you can call on them when you need to. Okay, so the next one is the short path. So let's quickly identify the difference. So both of them will destroy, or not make Alex do this, but make the agent do that. Remember, it will make the agent destroy a block, it will make the agent move forward, and it will make the agent place a rail down, okay? So in the long path, it's going to do this 3 times. So if there are 3 blocks that we need to break, and that we need to move forward to, and that we need to place rails at, we will use the fixed long path function. If there are only 2, you can see it's going to be the same sequence of codes, right? The same statements are being used, grouped together to do a certain function, but this will only do it twice. So we're going to use this one if ever we need to break only 2 blocks and move forward and place rails, okay? So what we did last time was we took the agent to the left here, and we used this fixed short path. So I want to do that quickly now, just in case we have new people. So we're going to turn left, and remember, turn left doesn't make the agent move, it just makes the agent turn in place. So we still have to place 2 move forwards onto our workspace, okay? Now we are faced with 2 blocks, so we are going to use the fixed short path. Before I continue, just type in the chat box a yes if you were able to access the link, and if you have it open on your computer and you can follow along. Okay, there's 1 yes. Okay. So I'm guessing 1 yes will have to do. Right. So now over here we fix this, or we place this fixed short path function. So what this is going to do is from here, We are going to destroy this block. Then we will move forward to stand on this position, and then we will place a rail. Then we're going to do that entire thing again. All three of those blocks will happen again here because it is in this repeat 2 that we have there. Okay. Now remember also, or take note that this place rails block will place a rail where you are standing. It doesn't place it before you because it doesn't say place forward. It just says place. So that is going to happen exactly where the agent is standing. Okay. So after we've done that, now we will end up here and we will be facing this way. So let's test that before we continue. Okay, there we can see the rails have been placed, so we are good to go. Now we need to make this agent turn right in order to go towards this longer path that we have to repair. And then we have to move forward twice again, 1 and 2. But this time you can see there are 1, 2, 3 blocks that we need to fix. So we are going to say fix long path. Okay, so now if you run this, you can see everything is still good up to where we've tested the code earlier. And now it's working. Now, you do not have to move that agent because Alex can move past the agent. So we can now use the arrows on our keyboard to move Alex around in the play area, or you can use these clickable buttons below the play area to move Alex, okay? Now Minecrafts, they are notorious for moving a lot, so you don't have to click each time. You can just get it to move and then it'll be good. When you are aligned with the flint, you have to get out of the minecart to pick it up. Okay. So that's the one way. But remember I said, when we are going into functions with the harvester, this becomes a lot more difficult. So I want to practice using functions now. So the way we are going to do that is we are going to say, okay, not only do we want to collect the flint, but we also want to collect the diamond. So now we need to find a way to get Alex to that diamond. So we could possibly bring the agent all the way around here, but in my opinion, why not just start this way and then go up on the right hand side? Okay. So what we have to do is to get the agent to face towards this, we are going to place a turn right block. If you accidentally drag the turn left onto the workspace, you can just click on the toggle and change it, right? You don't have to delete the block and place a new one. You can just change here between the directions. Then we have to move the agent to be in front of that, and we are going to move 1, 2, 3 times. So if we are doing the same action 3 times, it is shorter for us to use a repeat block because now we are using 2 blocks to do something that would have taken 3 blocks to do. Okay. Now we can see there are 1, 2 blocks that needs to be sorted out, so we're going to place a fixed short path in there. And then we test it because this sequence is now already complicated. We have a repeat and we have a function in there, but we can see that we are okay. We are still safe and on the right track. Okay. So from here, we are facing towards the workspace. So if we want to face the new obstacle, the second problem of breaking and fixing these, we need to turn left. And then we can count, there are 1, 2, 3 blocks there that we have to break and we need to place rails under. So we have to choose the function or call the function that says fix long path because you can see with that it is to do 3 of them. Now we can test this again. So remember, you cannot break this platform and you cannot really make mistakes that you will be penalized for. So you can test each time you create a new solution, you can test that solution. So now we're here facing up, but we want to be aligned with this here so that we can open that and fix that path there. So we're going to make our agent turn left. We will move forward twice, 1, 2. And then we are going to turn right over here, okay? So that we are facing these 2 blocks. So now we are going to run, and we can see that the agent is actually doing what we have told it to do earlier, so that hasn't changed anything. And now we can see that we are aligned with this here. So the final problem is the same as the first problem. We have had 2 blocks here to break, and there we have 2 to break. So we know we have a function already defined to fix a short path. So we can call on that function there, and then we run the code one last time. Okay, now you can see that the agent has done all of that breaking and fixing of the rail, and we can now move Alex around again using either these buttons to click under the play area, or we can use our arrows on our keyboard. So I'm using the arrows on my keyboard, and there you can see whenever it feels like it's becoming sticky, I just press on the direction again. Now I want to jump out to the right in order for me to pick up that diamond. And then I'm going to go back past, oh my goodness, past the agent, and we are going to collect that flint and steel. Okay. So what I want you to really take notice of is this. You can use repeats and functions in the same sequence. There you can see. You can use repeats inside your functions when you are defining your functions. That word slipped my mind there for a second. The amount of times you repeat within a function doesn't matter. The amount of blocks that you are using within a function doesn't matter, okay? And then this is probably the most important one. When we are using repeat blocks, there has to be a pattern. If there isn't a pattern, we cannot use a repeat block. Functions does not rely on a pattern. In actual fact, functions are there to make it easier for us when there are no patterns for us that we can easily identify. Okay, so that is what functions are all about. So we're going to practice using functions in one more puzzle before we move on to the next lesson. Our lesson 12 is free play in this Minecraft world. So for that, I'm going to leave that with you for homework, and then you can go and create some awesome stuff, and you can send me photos on that. And thank you for the student that has sent me a photo on last time's homework. I appreciate it. I saw it, and well done. You fixed that problem that we had there in less blocks than what we had to use. Okay, so tell me in the chat box, type a yes if you are ready for us to move on. Junior is good to go. Jesse is good to go. Okay, Angelina is good to go. So there, we are moving on. Okay. So now we see this is a crazy looking play area that we have here. So the first thing we need to take note of is this prompt. It says the agent can hover over lava, but Steve and Alex can't. So we are playing as Alex. If you chose to play as Steve, that's fine. But you need to take note that you cannot walk across the lava. There has to be a bridge for you to walk on. Okay. Secondly, look at the functions below. How can you use them to avoid the ghosts? Okay. Take note of that spelling, it's not ghosts. And help Alex make it safely to the enchanted book. So there you can see an enchanted book. Here we can see a lot of lava, and there we can see 2 ghosts. Now, ghosts are what you find in the Ender or Ender world in Minecraft, and they are not friendly. Okay, these are, remember we spoke about mobs in Minecraft before. These are monstrous mobs, and their aim is to hurt you. Okay. So for this, we are lucky because these ghosts aren't shooting anything. In the real Minecraft game, they actually shoot stuff at you. So the only thing that we really have to take note of is that we are moving past them and not moving into them, okay? Because that's what they say here at the top, avoid the ghasts. Now we can also have a look at the two functions that have already been defined for us. Now remember, for these two, we are not defining the functions. The functions are already there. They are predefined functions, okay? Sometimes it happens like that. If you and a partner are working on a program together, one might assign functions and variables, and the other one might be putting all of those things together into the actual code that will run the program. So it is good practice to work with functions that have already been defined by somebody else, but it is very important to understand how they went about defining those functions. So for this, code.org obviously had someone type here, build short bridge, and they've assigned these actions or this sequence to that function, and this says move forward and place netherrack. So netherrack is another type of block that you find in Minecraft in the nether, and I can't remember, I think it looks like this here on the side. Yes, these ones. So we'll see now when we use it. So this is going to repeat it 2 times, okay? Because we are going to build a short bridge. Then the next function says build a long bridge. So it's the same sequence, move forward and place netherrack, but doing that 5 times, okay? What I need you to also pay attention to is over here, we have a few blocks available for us to use. We have place netherrack and we have destroy block. So there are 2 ways to do this. Netherworld, says Jesse. There we go. Okay, but many people refer to it just as the nether. Okay, so the first thing that I want to do is actually just try to get the straightest line possible through here so that we are avoiding the ghasts. So we're going to say build a short bridge. Okay, because that function has been assigned or defined, we can already use it just as it is. And there we can see displacing the netherrack, and we are now faced with this block here. But we have something here. We have a destroy block available for us to use. However, if we destroy this block, there won't be anything under it. It's going to be lava. So once we move forward, we need to place 1 netherrack before we can continue using the function. So there we can see the block is broken. Oh, we are safe there. We don't need this place netherrack because you can see once the block is broken, there is something underneath it already. So we're lucky that way. Now we have 1, 2, 3 spots that we need to move. So now we can say, well, we don't really want to build a long bridge here, do we? Because we are going to only need 3. So we're going to build 1 short bridge, move forward, place netherrack. Let's run this and have a look. Okay, so there's another short bridge being built. And there we go. We have a very straight, direct path going to the enchanted book. The problem that I have with using this way is, as you all know, I want to collect the diamonds. But if we are using this straight path, we end up directly on the enchanted book. And once we've picked up that book, we cannot move Alex around anymore. So I want to use a different route to get there so that I don't end up directly on top of that. Okay. So we're still going to build the short bridge all the way to there. But now, instead of breaking this, I'm going to turn to go past it. Okay, so we are going to turn right. Then we are going to move forward. Okay, so we are here, we are turning, we are ending up there. Then I want to place netherrack because now we are definitely hovering on lava. So you can see there, when we turn and we move, there's nothing. Now there is something. Now we can count 1, 2, 3, 4. So it's still not completely 3, but, oh, I mean 5, but it shouldn't be an issue because there is space there to move. But before we can do that, we have to turn left. I forgot about the turn left. There we go. So that we are now facing towards that book there. Okay. Oh, I chose the wrong function. You aren't even helping me. We need to build a long bridge. We could have also placed 2 build short bridges there because we only need 4. But I think that's okay. Now we can get Alex across without getting the book immediately when we get to the next island, but we still can't move over that lava there. So we are going to add a very short sequence of code that's going to just help the agent move there and place us 1 netherrack. So from there, we want to turn right to face this way where the diamond is at, and we're going to move forward twice. 1, 2. That has to connect. So we're walking there and ending up hovering over the lava because the agent is not affected by it. And then we want to place netherrack there. So now if we run the code, now we can just walk Alex across here. And we have now collected the diamond. And we have now collected the book. Now there's one more way we can do this, and I have to show this to you again. If we do not practice functions very well, we are going to suffer. If you count the amount of blocks from here where they are to there, you're looking at 1, 2, 3, 4, 5, and a 6th one there. So what I think we can do is to make this a lot shorter. Now this last, we want to keep that because I'm aiming to end up there, and then we still want to build that 1 netherrack there so that we can get to the diamond. But what if we make the agent turn right first, move forward once, and then turn left? So now the agent will stand and face the same way and direction as Alex is. Then we build a long bridge and we build a short bridge. And then we do that. So let's test that. Look at that. Now we have a straight path across. We can get to the diamond and we can get to the book. And we are using 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks only to do that. Obviously, these also count as blocks, okay? So remember that. Let me just show that to you in the code. The function, there's the first function, short bridge. And there you can see when I said earlier, the binary has to be able to use these symbols, right? Pluses and parentheses, curly brackets, equal sign, and semicolons, all of those. And then this is the other one, the long bridge. There we go. And then here you can see the sequence of code that we've used. And there you can see we have called on that function there, and we've called on this function here. Okay. So these still count as blocks in your workspace. Don't forget that, right? So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 blocks. The difference being we did not create this, it was given to us. Okay, so I want to jump onto this puzzle because this is going to be a homework challenge, okay? Here you can see there is a play area, and I'm just going to run it and quickly walk with Alex around here, okay? So you can see there is a lot of things on this map. There's a house up there, okay? Perhaps you'll be able to do a few things here That'll be cool. But what you need to take notice of is the functions are empty. They have not been defined, function 1 and function 2. So the way to do that is you are going to, remember you can place some of these as well, okay? Look, all of these you can place. You can actually build an entire house here if you'd like to do that. You can place any of these blocks inside the function. You can actually repeat that block if you want to. Okay, you can set how many times you want to repeat it. You can't repeat more than 10 times, so just keep that in mind. And you can click here to change the name of the function. So let's say this is your move function, and this is your destroy function, right? And you will see here, the names of these also change when you change them there, okay? So I'm going to share this link with you. Keep it open now once we've said goodbye, and then you can go ahead and you can program something into this using functions and share it with me on my email address. So this is the free play that I've just shared the link with to you, or the link to with you. And then join us tomorrow. Invite your friends. We obviously start at puzzle number 2 because we didn't get to it today. We are going to do functions in the harvester. This is a very difficult and much more advanced lesson, so we will not be speeding through it, okay? Thank you so much for being here. Again, invite your friends, and please send what you've done and share your creations with me. There's my email address. You can find Africa Teen Geeks on these following social media handles. Have a great day, and I'll see you tomorrow. Bye-bye.